Example. We have several different rules that we're applying to solve these problems, right? We're going to go over these rules and we're going to go through it through every step of the way. So we want to work on the variable side. What side is the variable? Yes, this side. Do we understand? Okay, let me see thumbs up or down real quick, please. Okay, good. All right, simplify as possible. Is there anything for us to simplify here?
No.
No, we have no like terms, right? So remember the example of the 6x and whatever the other one was, minus 8x? Does anyone have money in here? Like a 5 and a 1 by chance, or a 10? Anything? Any type of money? I want to show you something. Show you an example. No one.
I have a $2 bill.
I'll take it. I'll give it back to you. Swear. Anyone else by chance? Even $1 will work. Okay. Thank you. You don't see these too often anymore. So let's pretend for a minute. Let's pretend that he has a $2 bill and a $1 bill. How much money does he have? 3, right? So we took the 2 and we combined it to the 1, so we combine like terms, right? Okay. That's all combining like terms is. Simplifying numbers and or simplifying variables. Now the variables have to be the same, right? And they have to be the same power. Okay. So there is nothing to simplify here, right? So we're going to move on. We're going to do the inverse operation. What the inverse operation is, it means doing the opposite from one side to the other. What's the other side? Baca, you know this? You shined on this. What's the other side? What's the other side of an equation? You know. Right there? The equal sign? The other side of the equation is the equal sign. The whole idea is we got to keep the problem balanced. Okay? So, we're going to do the inverse operation, so both sides, we're going to work with a variable last. So Hector, what that means, we're going to minus 4, aren't we? Okay, let's go ahead and do that. Minus 4. Now, what do I do now? I do it to the other side, right? Say with me, Chris. Come on. Yes. So we're going to cancel this out, and we're going to write minus 4, draw a line. Everyone do that, please. Hector, do it, please. Come on. Okay, so we moved it to the other side, right? So we can go ahead and solve this. What is 15 minus 4? 11. Very good. 11. Is it positive or negative?
Positive.
Right. It's positive because, don't worry about positive and negatives. We're still subtracting, right, at the end of the day? Whichever one is larger retains a symbol. So the larger one's positive, so it's going to eat up the 4, right? Good. Excellent. Now we're going to bring down the x6 over 6. No, not right now. This we've been working on. Let me fix that 11 so it looks a little better. It looks a little foreign. So we're doing two-step or multi-step, right? So now, what type of math is this right here? No. What type of math is that? It's a fraction, right? Very good. And what's the opposite of dividing? Very good. Put 6 in the parentheses. Go ahead and do that, please. What's that? But let me get through this and then I'll help you. Okay, now that we did it to one side, right, we're going to cancel this out, and we're going to put it on the other side. Any questions so far? Okay, let me see thumbs up or down whether we have this. Wilson, please. Okay, good. Baca, are you good? Okay, awesome. What's 11 times 6? 66. Are we done with the problem? We're done. We're done. We solved it. Now, we're actually going to do this problem again because I want you to see something, okay? How many looked at that problem and said, I don't know how to solve it? Being truthful. If you know these steps, you know how to solve all these problems. There's some little things go on, but we're going to go through this. This is a pretty good representation of what the test is going to be. So BMW, when I ask that question, what does that mean? Or when I put that out there, what does that mean? Besides that, where are you going to find some of these questions? Where? Hector, say it again. Say it again. You got it right. Say it again. Oh, that sucks. Some of these same questions are going to be on test. Same exact ones? Same exact ones. Same exact ones. So do you really want to be engaged?
Yes.
Yes. I love going over. All right, let's go through this. So variable side, right? We're going to subtract 4 from both sides. That's our first step. Why do I do this? It shows where it originated. So I know I moved it over here to over here. Okay? So then I bring down the x over 6. There's my first step, right? And then I multiply by 6 on both sides. And we have the answer. X equals 66. Okay? Yes? Was that a hand up or no? Or? Okay. Okay, so let's look at this one. Anyone know how to solve this one?
Yes.
Okay, let's work through it. Baka, stay with us, please. Okay, so you should have this written out on the first one, right? Okay, let's go to this one. How do I start it?
Subtract 1/4.
Very good. Subtract 1/4. BMW, do you agree?
Yes.
Yes. What do I do with it now that I'm subtracting it?
Check the other side.
Other side. And the other side is what? Equal sign. So it helps to cancel this out, right? Okay, let's talk about this. How many in here know how to subtract that? If you don't, it's okay. But there's a rule, right? What's the rule?
You have to get the same denominator.
Very good. We have to have the same denominators. Now, I'm going to show you the easiest way to do this. Does 4 go into 12? It does. So watch this. Write 12. Write 12, write 5. I'm not going to make any changes to that one. I'm just going to make changes to this one. Okay? Wilson, write it down, please. Bill, if you get a moment, can you come to my class, please? Thank you. Okay, what's 12 divided by 4?
3.
3. So this is what I do. I put 3 inside the parentheses. Okay? What I do to this one, I have to do to this one. So I'm going to put 3 up here. What is 3 times 1? Okay, didn't we just convert this? Yeah. Believe it or not, this number and this number are exactly the same thing. But we need to have a common denominator to be able to subtract. Okay? So this one's positive, this one's negative. Which one's larger, the positive or the negative? The positive. So we're not concerned about the symbol, right? We don't do anything with the denominator. We bring the denominator down. What is 5 minus 3? Hector, your time to shine. What's 5 minus 3? You got a calculator right there? Your time to shine, buddy. 5 minus 3. We'll wait for you. 5 minus 3. We'll wait for you. You got a calculator inside of your desk? Yes, awesome. Thank you. Okay, so we took care of the fraction, right? Now all we have left is this. We haven't done anything with this yet. Now, Ruben, what do I do? How do I solve this now? Right? And let's go through this slow. I subtracted it from both sides, right? I had to convert this fraction to 12 before I could subtract them. So that's what this step is. Then I bring this down, and I bring this down, right? Now how do I solve that?
Flip 1/3.
Very good. Flip 1/3. And how did you know that?
Why wouldn't you flip to 4?
That's an excellent, excellent question. We always work on the variable side, right? And we deal with the variable last. So if we subtracted this to the other side, we just changed order of operation because we subtracted before we multiplied or divided. Okay? Now let me show you why we do the reciprocal. What's 3 times 1? And what's 1 times 3? The same thing, right? So it's 3 over 3. And 3 over 3 is what? 1. So in algebra, every variable has at least a value of 1. So that's how we do the inverse operation. Okay? Okay, from here, we did it on this side. What do we need to do now?
The other side.
Very good. So we're going to write 3 over 1, right? Put this in parentheses. Now, Ruben, I have a question. Can I reduce this? I can. How can I reduce this? What goes into what?
3 goes into 3 one time.
Very good. 3 goes into 3 one time, and how many times does it go into 12?
4 times.
Okay. Now what do I do? How?
2 times 1.
Give me some rules. What am I doing? I'll give you a little hint.
Left to right.
And down.
Yep. Numerators by numerators, denominators by denominators. So just straight across, okay? So what's 2 times 1? And what's 4 times 1?
4.
Okay, can I reduce that further?
Yeah.
Yeah, 2 goes into 4 how many times? So what's my answer? Very good. So we took all that problem when we solved it.
I also.
Now, do you want me to go through it one more time?
This one.
Yes.
I got 2 12s and then you did 3 1s, so it would be 6. And 6 over 12 is 6 over 12 is 1/2.
Okay, yeah. The only thing you didn't do was cross-reduce. The reason why we cross-reduce, in math, you're always trying to make that problem smaller to make it easier. Right, Hector? We're trying to make it smaller every step of the way. Okay? Makes it easier to solve when it's done. Yes, Ruben?
Can you go over that part again?
We're going to go over the entire thing again. Okay.
So y is 1/2.
Yes. Y is 1/2. Very good. Now, do you see how when you know the rules and you know the steps, how a problem that looks like this, they're like, oh boy, I don't know about this one, right? Once you know the steps, it's pretty easy to do, right? Some of you have had this before. You just need a refresher.
Why are A and C the same?
I'm sorry? This one right here? Because I was going to write it twice.
So there's no C.
Shh. Okay, so looking at this problem, how do I start with this one?
On the variable.
On the variable side, then what next?
So 1/3. 1/4.
Very good. Minus 1/4, right? So we're going to deal with the variable last. We're going to do the opposite of this to both sides, right? So this is going to cancel out. And then we need to change this fraction. What do I write right here?
3 12s.
12. Okay? And 12 divided by 4 is what? Okay, and then I multiply 3 times 1, correct? Someone say yes.
Yeah.
Okay. Now we can subtract these fractions, right? And Hector gave us the answer. It was 5 minus 3, which was 2. Right? So we're 2 over 12. Are we good so far?
No.
No? We could reduce that, couldn't we? We could, or we could leave it. We want to reduce it when it's all said and done. Right?
What did everyone say?
Yeah. Because 2 goes into 2 once, and 2 goes into 12 6 times. So let's reduce that to 1/6. We get the same thing when it's all said and done. So this is what we have left on this side, right? And then we have 1/3 y. Then Ruben, you told us to do the inverse operation, right? Which was 3 over 1. What do we call that vocab-wise? Yep. Is this going to end up the same way as how we did the first time, even reducing the 12? Yeah, it's the same thing. So notice here, we can reduce these two, right? Because 3 goes into 3 once, and then 3 goes into 6 twice. Then it reduces to 1/2. Now, isn't this kind of a great example of why you always want to reduce? It made this problem a lot easier, right? Shorter. Yeah. Less steps at the end of the day. Okay, let's look at this one right here. Isn't this one exactly the same thing?
Yes.
It's exactly the same thing. So let's work through this. You guys tell me what to do here. How do I start this problem?
Plus 1/7.
Yes, plus 1/7. Then what do I want to do? Yep, other side. So what do I do here?
What do you plus 4? Or you reduce? Like
It'll be 214.
Right, I want to change this to 14, right? I need 14. 7 goes into 14. They're divisible by each other, right? I need the same common denominators to be able to add or subtract fractions. So 14 divided by 7 is what? Okay. So then I multiply the 2 times 1. Aren't these two numbers the same thing? They are. They're the same thing. This one is, oh, we're adding here, right? So we're just adding these together. So we bring down the 14, and then what's my numerators? 5. Good. What do we have left, Mercedes?
2/7.
Okay. What? 2, 7 what?
Yeah.
Okay. So I got a fraction next to a variable. What do I do? Very good. What do I write?
7 over 2.
Good. Now what do I do?
10 over 2.
Other side. Can we reduce these?
Yeah.
We can. We can reduce them right here, can't we? So 7 goes into 7 once, and 7 goes into 14 twice. Makes this problem a lot easier, right? What's 5 times 1? And 2 times 2?
1.
Oh. What happened?
2 and 1 half.
Hang on. I did something on purpose. Is this the right answer?
No.
What's the answer?
2 and 1 half.
What's 2 times 2?
4.
Okay. Now, what do I have here?
The top is right.
And why is it improper?
You make
Yep, the top number's bigger. Okay. So how you do this? Calculators out, please. Everyone? Calculator, let's go. 5 divided by 4 is what?
1.25.
We're going to wait on Hector. 5 divided by 4. Give me the answer, Hector. What does it say? Hector, what does it say? Come on. 5 divided by 4. You don't know? Okay, someone help him push it in the calculator, please. You got multiple students helping you out. It's what? Okay, so we just focus on that whole number, right? Just the 1. That's all we're concerned about, right? Ignore the decimal. Everyone following? Okay, so what we do is 4 times 1 is what?
4.
Okay, and 5 subtracted by 4 is what? 1. And then we carry the 4 over. Let me go through this a little bit slower. These were the improper fractions that we did, right? Ignore the decimal, use the calculator to find the whole number. Okay?
So why you do
Okay, so let's do this. Your time to shine. What's my answer here?
3 and 1 half.
Yep. 2 times 3 is 6. 1 left over, 1 over 2. Does everyone understand this? Let me see thumbs up or down on this. Everyone, let me see thumbs up or down on this. Ruben, thumbs up or down on this. Oh, wait. Thumbs up or down on this. Oh, yeah. Bucket, you good? Okay. That's how we turn them back proper. I have a question. How do we turn a regular mixed number to an improper?
Whole numbers are times the denominator plus the numerator.
Excellent. Excellent. What did she just say? This is what she said. Watch this. What does dot mean? Okay. What does a plus mean? Okay. What direction is this? Is it? Clockwise. Okay. So it goes this way, right? So what is 2 times 3?
6.
Plus 1?
7.
7 over 2, right? That's how we turn it back improper. Okay? If you remember the arrow and then it's a dot and plus, you'll never get this wrong. Okay, we good so far? Do I need to go? Would you like me to go through this one again? Or are we solid on this? One more time? One more time? We're good?
Yes, sir.
Okay, one more time?
No, we're solid.
Okay. Well, it's the whole class as a whole, right?
Can you give me back?
All right, Ruben. Your time to shine, buddy. Make things happen. And go.
Plus 1 is 7.
Okay?
2 is 7.
Okay? And then what?
Yeah.
It and
Yeah, and then that.
okay, we're adding these two together, right?
Yeah.
So 3 and 2 is what?
5.
This. Okay, tell me what to do now.
Numbers operation.
Very good. So what am I going to do?
Add 7 over 2.
Good. These cancel out?
Yes.
Yep. Now what do I do?
Other thing, same thing.
The other thing? Where we that is right. Okay. Cross cancel.
Yeah.
Goes in once. Goes in twice. What's 5 times 1?
5.
And 2 times 2?
4.
What's my final answer?
1 and 1.
1 and 1.
Very good. Good job, Roman. Who wants to do this one? Why not? Isn't this easy? Isn't it the same exact thing?
No. Yeah.
All right. Even though she hasn't been here, one of my faves. Shivers, will you help me do this problem? That's a yes.
No.
Okay, we work on the variable side, right? By the way, this is an A over 3. Okay? So I'm going to work on this side, right? What am I going to do now? Same thing I did here. What am I going to do here? What's the opposite of this? Good. Good. You gave her a lifeline, too. Okay? Now what do I do with it? Good. We got all this nonverbal communication going on to get excited. So that cancels out, right? What is 15 plus 2?
17.
I try not to make that look like a 9, but I'm so used to doing it. Okay, what do I do here? I got a fraction, right?
On the other side.
One more time.
17 on the other side. Put a 1 under it.
Woo!
Something more brilliant.
Let's look at our rules. What side do we work on? Hey! So what am I going to do now? What am I going to do? I'm not going to touch that 17, right? Because I want to work on the variable side. I have A over 3. What type of math is that? So how do I undo it? Okay. BMW, I will tell you something. That's a common mistake made. You never work on the equal side. We're always trying to get the answer to the variable, so we're always working on this side. This is just a net result of whatever's happening when it's all said and done. So someone tell me what 3 times 17 is.
I don't know.
Like 50 something?
Like 50 something? Is 50 something an answer?
No, 54.
How much is it?
51.
51. I would agree. Put it in your calculator. You got it right in front of you. So we solved this problem, did we?
No. No.
You sure?
Oh yeah.
We have A by itself, right? That was a 9, I swear. We're done. We don't have anything left to do. We solved. We have an answer, right? Okay. Hector, let me see eyes up, please. Okay, let's talk about this one, Baca. Help me with the first rule. What am I going to do? What side am I going to work on? How am I going to start this problem? Yeah, you do.
You're just so
The left side.
Okay, yeah, he said the left side. Is that right?
Yeah.
Yeah, the left side because the variable's on the left side, right? We never work on this side.
No.
Okay? So, we're going to deal with the variable last. What is this right here? Okay, how do we get rid of 4? Subtract 4. Could we put a 1 on there? I guess. It wouldn't have mattered, though. So this cancels out, right? What's 10 minus 4?
6.
Okay, equals m over 2. How do I solve this right here?
You put 2 on the other side.
Right, because it's division. It's a fraction. Anytime you see fraction, you know it's dividing. To undo it, you want to multiply. Okay? I showed you guys why, right? I've showed you.
So you would put a 2 on the side.
We're putting a 2 on the outside and a 2 here. So let's talk about why this gets rid of itself. Okay? Mercedes, what is under this that we can't see at the end of the day? Yeah. So this becomes 2 over 1, because we don't know what the m is, times 1 over 2. What's 2 times 1?
2.
What's 1 times 2? What is 2 times 2 reduced? Yeah. So in algebra, we always have an imaginary 1 in front of a variable. There's at least a value of 1. And that's why this cancels out. That's why we have a fraction, means division. We do the opposite. That's what cancels it out. Are we clear?
12?
I'm sorry?
Yes, sir.
M is 12.
Yes. M is 12. Very good. M equals 12. Are we done?
Oh, no.
Are we done?
Yes, sir.
Yes, we're done.
Wait, would you get it wrong? You know how it's 12 over 2? Oh, no.
Are you good? You want me to do it one more time?
I'm good, but like, wouldn't it be 6? But 6 is already there. There.
So let's do this one more time.
No.
Variable side, plus 4, minus 4, both sides, right? 10 minus 4 is 6. Division, multiply, multiply. Hector, let me see your eyeballs, please.